So yesterday we have discussed related to the data transfer instructions, and today we will discuss arithmetic instructions. So before that we will again revise the concept of data transfer instructions. In case of data transfer instructions, we have to simply transfer the content of source registers into the destination register, or simply we say that the source operand into the destination operand. In case of assembly instructions used in 8051, this is first part is mnemonic, second part is destination operand, and third part is your source operand. So whatever contents allocated or belonging to the source operand, they are simply copied or loaded, stored into the destination operand. Okay, so this is the procedure. We cannot modify the data, only transfer the data as it is, either from uh, register, either from memory contents or memory locations, that is memory pointer, either in ROM, RAM, whatever, or simply immediate value, that is direct data. Okay, so this is related to the data transfer. So only transfer the contents, not process or modifying the content. Second type related to the arithmetic instruction, that is whenever 8051 performing arithmetic operation like addition, subtraction, multiplication, division, increment, decrement, and last one is decimal adjust. Okay, so in this case, whatever the contents belonging to the source operand are modified according to the another operand. So in this case, we will consider initially, that is before execution of instruction, mnemonic operand 1, operand 2, instead of saying source and destination. So here we call operand 1 and operand 2, and after performing that required or respective operation, suppose in this case 1, add a comma hash data, whatever contents are there. So this data, that is content, will be added with the content of accumulator, and final result will be loaded in accumulator. So in this case, destination is accumulator, but before that it will act as a operand also, that is it will add the content with another operand's content. So whatever content belonging to the accumulator before execution of this instruction, they are simply added with the data, that is whatever the 8-bit number is there, and after that addition, whatever result is generated, it will be copied or loaded, stored into accumulator. So in case of arithmetic operations, on rather for logical operations also, the result is always stored in accumulator. So if you see the description part, arrow is indicating that result is stored at accumulator only, whatever the operations are to be performed. Okay, so after that we will discuss related to the uh, various structures related to the accumulator. So in case of arithmetic operations, one operand is always accumulator. If you see that one operand is always accumulator, and another operand may be data, maybe registers content, maybe memories content, or maybe memory pointer pointed by RI, that is R0 and R1. So these two, that is direct and RI, are the memory pointers, and RN is your register, and hash indicates the exact number or specific value which will be added, subtracted, or multiplied with the content of accumulator. So in case of arithmetic operations, you simply consider one operand is always accumulator, another operand it may vary, either data, either content from register R0 to R7, B register. Okay, and next operand is related to the direct memory locations content. So whatever the contents belongs to that memory location, so these contents are added with the content of accumulator, that is add a comma direct, that is add a comma 40h, suppose. So 40h, so 40 is not added with content of accumulator. So on or at 40h memory location, whatever data is loaded, that is 02h, 03h, whatever contents are there, so these contents are added with content of accumulator. Similar for a comma at the rate ri, that is add a comma at the rate ri. So here ri we consider the r0. So add a comma at the rate r0, and before that we have defined that r0 is nothing but your 20h. Suppose move r0 comma hash 20h, as we have already seen. So from that 20h memory location, whatever the contents are there, they are simply added with the content of accumulator. And after performing this instruction, whatever result is there, it will be automatically loaded into the accumulator. So accumulator consists always an result after execution of an instruction. Okay, who is there? Abhishek Mane. So we see, similar to the earlier case, if we see in that in an Excel file. Suppose org00h is your first instruction. Move a comma hash 02h, which is second. So screen is visible to you? Move
Yes, sir.
r0 comma hash 40h. We consider that if you want to content r0. Okay, see. So regarding this, if we consider the first instruction, that is clear. Okay, so first instruction is content of accumulator. So a belongs to 0 to h, 0 to h, and r0 is nothing but your 40h. After that, if we, and again we draw or analyze the memory pointers, that is 40h, 41, 42, 43, 44. Okay, so in this case, suppose the contents are like 3, 9, 6, whatever, or simply we say the table of 3, 12, 15. So belonging to that. So if we want to execute and add a comma hash 04h. So after execution of this instruction, add a comma hash 04h. Here 04h is nothing but your content, immediate value. So whatever the result is after execution of this, a is equal to, hello,
06 hex.
06 hex. Okay, so this is the addition of immediate value and content of accumulator. After that, we see add, sorry, a comma at the rate r0. Now tell me, content of accumulator becomes other than Prajakta. Somebody tell. Suraj Jadhav, are you listening? More Rishikesh, are you there? Rishikesh More, Abhishek Mane. Hello, Mane Abhishek. If you are listening, reply me. Whatever result is there. or just simply say I am present. Aishwarya Gadarji, are you listening? Hello? Aishwarya Gadarji, are you listening? So I will consider these candidates are absent for today.
Present, sir.
So why you are not responding?
Present, sir.
You are waiting that I am
Huh.
saying that you are absent. Tell me, what will be the result after add a comma at the rate r0? Hello?
Hello? Huh.
The content of accumulator after execution of this instruction, that is at a comma at the rate r0. What will be the contents? Hello?
Hello? Huh.
What will be the contents? Please.
44.
Kiti? 40.
4.
Okay. 40 or
Huh.
4? 40h. 4 or 40h?
40th.
40h. Okay. I have put it here 40h. So next candidates, who will be tell? More Prajakta. Is this right answer?
No, sir.
What is the answer? Tell. What is the answer? You calculate and tell whenever you got the answer. Vaishnavi, roll number 10. Are you there?
Yes, sir.
What is the answer or content of accumulator after execution of this instruction?
42.
42. We are talking about content of accumulator, not memory pointer. I have put it here, but this is wrong answer. Doke Ashwini. Or you want to say something? Doke Ashwini. Your roll number is missing. Okay. Doke Ashwini.
Sir, 09.
Who is talking?
Prajakta.
09H 6 and after that at the rate R0 40. Okay, good. 09H. So here A becomes 6. After that we want to add the content of at the rate R0. That is R0 is specified to 40H. So 40H contents are 3. So here addition of 3 plus 6. So 3 plus 6 is 9. 9 is your right answer. Okay, so in case of this, see, this is your immediate value. And here, initially, it looks like immediate value assigned to the R0. But whenever we use at the rate symbol for that register, it will become some memory pointer. And at that memory pointer, whatever the contents are loaded, stored, these contents are operated for addition, subtraction, division. Okay. So after that, if we consider SUB, subtraction or multiplication, whatever the contents are there, it will be carried out. So in this case, see, addition without carry, addition with carry. So add C is nothing but your addition with carry. So initially in case of add instruction only, that is ADD, we do not consider the carry flag status. So only addition between these two contents, content of accumulator, immediate value, content of accumulator here, sorry, immediate value here, content of accumulator and memory pointers content. So we have to make addition simply and result is stored in the accumulator. But whenever we move towards the add C, a comma, hash 05H. In this case, if initially we consider that carry is 1, Cy or C is equal to 1 because of earlier sum operation, if carry generated and that too set as a 1. So after execution of this instruction, suppose earlier content was 9, so 9. After that 5, and again 1. So whatever the contents are there in hex value, they are added here. That is, addition will be done with the help of or through carry when we use instruction add C. If it is 0, no problem. And if it is 1, it will be added to the your result, whatever the result is there. Okay. So in this way, carry flag plays an important role where we want to add carry bit, that is carry status, as our earlier operation. So this condition is mostly useful while going for 16-bit addition. 16-bit addition. So 16-bit addition is performed like this. Suppose 25 1 0. Hey, content. We want to add 1 0 2 0. So in this case, accumulator is loaded with this register. Another one register is loaded with this value. So two operands like 10H and 20H are loaded in two different register. One of them is accumulator and other one is suppose R0, R1, R2, whatever. So after that, whatever addition is performed, result is loaded at accumulator only. And if this addition generated a carry is equal to 1, इथं आपण carry consider करूया. See, the carry 1 झाला असेल, त्याला आपण mark करूया. Okay. From this addition, if carry is generated and it generated to the 1, whatever the content is there. So while accessing or addition of next higher byte, it will consider the carry flag also. So it will add 25 plus 10 plus 1. Here it looks like not generated. We see 9 0 and here 4 0. Okay, so it looks like carry may be generated. So whatever carry generated, according to that, it will be added, and whatever result is there, it will be at accumulator only. So in case of 16-bit addition, this is your higher byte and this is your lower byte. So when we want to perform a 16-bit addition, that is this, तुम्हाला करायचं आहे काय, 2590H plus 1040H हे तुम्हाला परफॉर्म करायचं आहे, रिक्वायर्ड असेल. अँड इन दॅट केस हे ऑपरेशन असं परफॉर्म होणार असेल तर बिफोर दॅट यू हॅव टू सिलेक्ट टेक, दॅट इज move a comma hash, first value घ्या, lower byte 90H, sorry 90H. After that take another register to take the another lower byte. So move R5 comma hash 40EH. So now we have considered two lower bytes, these two lower bytes 90 and 40 in two registers. One operand is always accumulator, another one is another register. Here you may take B register also, A and B. After that you have to perform the addition, that is A double D, add A comma R5. Okay, so whatever result is there, it will be loaded into the accumulator. Okay, so A becomes 40 90H. रिझल्ट काय येईल बघा, 30 ना आणि कॅरी 1 बरोबर, 30H and C is equal to 1. हेक्स व्हॅल्यू ऍक्च्युअल कॅल्क्युलेटरवर केल्यावर कळेल, कन्सिडर करू आपण 0 and 943 carry 1 suppose. Okay, or you would consider decimal values there. So when carry generated 1 and result of lower byte is also loaded in accumulator, and after that you want to perform the addition of higher byte from these two different numbers 25 and 10. In that case your lower byte result should be stored at different register. So store move R6 comma A. So here R6 will be loaded with the lower byte result. Suppose consider that 30H is your lower byte result. So this is your lower byte result. Lower byte. Okay. After that, this is completed from your side. Carry is also generated. We consider that carry is also generated. Then we want to take these two numbers in two different register, and among that move a comma hash. Which number is there? Suppose 25H. Next is that move R5 comma hash NH. Okay, you may use capital letters or small letters. Okay, so in this case again we are taking two numbers in two different register. One of them is always accumulator and another one is other register, either R0 to R7 or B register. So after that you have to perform again add a comma R5. So here if we simply mention add a comma R5, in that case whatever the contents in these two numbers, that is 25 and 10, these two contents are only added. Here carry flag is not considered. But whenever carry flag is generated, in that case you have to consider the carry flag status, whatever it is. So basically when it is set, that time your result is malfunctioning or wrong result may be generated if carry is not considered. And when it is not carry is not generated, in that case your results are okay, that is correct. But you consider that carry may be generated at any time. So here instead of writing add only, you should write add C a comma R5. So whatever result is there, result is like a plus R5 plus carry. A plus R5 plus carry. This formula घेतला इथं काढून टाकतो. होईल इथं तुमचा ऍक्च्युअल रिझल्ट जनरेट होईल जर कॅरी केला असेल तर. अदरवाइज इट विल बी नॉट गिव्स अस द राईट आन्सर. आर यू क्लिअर? आता हा जो रिझल्ट आहे तो परत कुठे स्टोअर झालाय? अक्युमुलेटर मध्ये. परत एकदा काय करा, मूव्ह करा. मूव्ह सपोज R7 कॉमा A. मग इथं R7 जो काय असेल, R7 चा रिझल्ट जो काय असेल तो H. ओके, तो काय असेल तुमचा हायर बाईट. इथं तुमची काय झाली, 16 बिट ऍडिशन परफॉर्म झाली. हा असेल लोअर बाईट आणि हा असेल तुमचा हायर बाईट. ओके, R6 लोअर बाईट, R7 हायर बाईट. क्लियर आहे ऍडिशन? हॅलो?
Yes, sir. Clear.
So this is related to either 8-bit addition as we have seen here or related to the 16-bit addition. Okay, we simply say here the 16-bit addition. So while performing 16-bit addition, we split the number, given number, that is 2590, into two parts, lower byte and higher byte, that is 8 bits. So here this is 16-bit. Here also split into two parts, lower and higher. So 40 lower byte, 10 higher byte. So initially you have to take the lower byte numbers, that is 90 and 40, into two registers. Out of them, one is always accumulator and another operand is other register from R0 to R7 or B register. So perform addition. Here in this case, that is first addition. It is not mandatory to use or study the status of carry flag. So here not necessary or required, add C. So you simply mention add A comma R5. And if you want to perform here also with the carry, then you should make initially carry flag is equal to 0. That is CLR C. So in this case, C becomes 0. When we use CLRC instruction, in that case, whatever initial operations are there or earlier operations are there, if carry is generated, so after execution of this instruction, that is CLRC, carry is automatically cleared. And in this case, when we are discussing related to this carry, add C, A comma R5. So it will consider that when carry is generated, it will be added. If it is not, it will be considered as its value is 0. So whatever contents from A and R5 will be simply added. So this is related to the addition, and similar operations are there for subtraction also. Okay, so same operations are there used for subtraction, only instruction change is SUBB. Here SUBB means subtract with borrow. Here in case of addition through carry and without carry, that is first add is without carry and add C is through carry. Addition is performed through carry. So here two type is there, with carry and without carry. But in case of subtraction is always taken with the help of, that is, or through carry. Here carry is nothing but considered as a borrow. Whatever borrow is generated, it will be considered as a borrow, and procedure is same. First operand or one operand is always accumulator, another operand is always either data, either content of register, either content from memory location, either content from a memory pointer register, indirect addressing. Okay, so according to that, number of bytes required are mentioned. So how many bytes are required and how many cycles are required? Bytes are required